Okay, so we've talked about this two-dimensional grid, the two-variable coordinate system. It's called the Cartesian coordinate system because it was, as we said, designed by René Descartes. So what we're going to look at is what is it used for? Other than just plotting points like that and mapping out locations, you can see the obvious. I'm sure you've all used maps where we had, along one side there might be letters. Come on, why won't you draw? Apparently it was, and just wasn't showing up. Okay. So obviously we can have that grid set up, and I'm sure you've seen maps where it's like A, B, C, D, and whatever across the bottom. 1, 2, 3, 4 up the side. And they say your location is at D3. So that means that you find D, and somewhere in that band above D and somewhere in that band beside 3, somewhere in that section is where that item is located on that map. So there's obvious benefits there, uses there. And in CNC, it's how you control the tool. You have a home point down here. That is your 0, 0 point. And then you'll be going over whether your system is set up in inches or whatever. You might be going over here to a point that is 1.287 inches this side and 0.318 inches up, and that's your location of that tool. Well, today we're going to look at mathematical applications of these graphs. And what it is for finding solutions to equations. We have solved equations that look like this. Seven equals 2x minus 1. How did we solve that equation? You would add the 1. So 8 equals 2x. Then we would divide by 2. So 4 equals x. So x equals 4. We could have another equation that might look like this. What would we do to solve this one? We would add 1. 12 equals 2x. And then we would divide by 2. So 6 equals x, or x equals 6. The steps to solve those two equations were exactly the same, even though the results were different. The solution is different. In fact, we could have 3 equals 2x minus 11. Our steps to solve it are going to be exactly the same. Add 1 and divide by 2. Now we get 2 equals x. All that was different here was this first number. These are what we call a family of equations. And we can represent a family of equations like this. Y equals 2x minus 1. And that represents all of those equations that would have that form of a number equals 2x minus 1. To represent that y equals 2x minus 1, to find the solutions to that all at once, we're going to put them on a graph. In order to put them on a graph, we're first going to make a table. And in our table, we're going to do this. We're going to pick values of x. Now remember, x we said was the independent variable, the independent axis. We can pick values for x. I'm going to try values across the graph. So I'm going to do like -2, -1, 0, 1, and 2. Once I've picked those values of x, the values for y are determined. They depend on the value of x and the formula or the equation. So if x equals -2, y equals 2 times -2 minus 1. I'm going to pause. Any questions on where I got that 2 times -2 minus 1? I just took the x equals -2. I put that into my equation where the x was. And then that's just this side here. Y equals that expression. I replaced the x with -2. So 2 times -2 is -4 minus 1 is -5. Perfect. So when x is -2, y is -5. So -2 for x, 1, 2, 3, 4, 5 for y. There's that first point. X is -2, y is -5. Well, when x is -1, y is going to be 2 times -1 minus 1. What's that come out to be? 2 times -1 is -2, minus 1 is -3. So when x is -1, y is -3, gives us that ordered pair. -1, -3 is right there. If x is 0, y is going to be 2 times 0 minus 1. What's 2 times 0? 0 minus 1? -1. So when x is 0, y is -1. So over here, 0, -1 is right there. When x is 2, y is 2 times 1. When x is 1, I should say, y is 2 times 1 minus 1. What's 2 times 1? 2. Minus 1 is 1. So when x is 1, y is 1. So we've got 1, 1 there. And finally, when x is 2, y is 2 times 2 minus 1, which is 3. 2 times 2 is 4, minus 1 is 3. So when x is 2, y is 3. So over here, x is 2, y is 3. And we see we get a straight line on our graph. So I can draw the line right through those points like that. What does that line represent? Well, every point on that line is a solution to this equation. If I put a line here, I might trace that down to x equals 5. Trace it over here, if y would be 9. So that's telling me that when x is 5, y is 9. That's the solution to that equation. If I put in 5 for x, I get 9 for y. Or I might go down here and find a point on the line. I trace it up here to -4. Trace it over here to -9. Gives me the point -4, -9. That's telling me that when x is -4, y has to be -9. Every point on that line is a solution to that equation. Now, not every equation is going to form a nice, perfect straight line like that. We might have y equals x squared. Oh, let's see here. Plus 2x minus 3. So we're going to pick some points for x. And figure out what y has to be. Now, because this is going to take a little longer or a little bit more space rather than filling in all the points I'm going to use for x right now, I'm going to do them one at a time. So I'm going to start with -2 for x. If x is -2, I put then y equals x squared plus 2x minus 3. I put in -2 for x, so it's -2 squared plus 2 times -2 minus 3. Now be careful with your calculator. Remember, if you were to punch this all in your calculator, you have to do it like I have here with the parentheses. Otherwise, that -2 squared might come up as -4, and that'll throw your answer off by a lot. -2 squared is +4. 2 times -2 is -4, and then minus 3. 4 plus -4 is 0, minus 3 is -3. So when x is -2, y is -3. So there's our first ordered pair. There's our first point on the graph. Now I might try, let's do x is 0. If x is 0, what's my expression for y going to be? I put in 0 wherever x is, so 0 squared plus 2 times 0 minus 3. Well, of course, 0 squared is 0. 2 times 0 is 0. 0 plus 0 minus 3, -3. So I get when x is 0, y is -3. So 0, -3 is another point right there. Let's try x equals 2. If x is a +2, what's my expression for y going to be? Perfect. 2 squared plus 2 times 2 minus 3. 2 squared is 4. What's 2 times 2? 4. 4 plus 4 is 8 minus 3 is 5. So when x is 2, y is 5. Well, we can pretty much rule out this one being a line right now, can't we? There's no way that forms a line. To figure out what it looks like, we need to find more points. So, and this is what I usually do, is put 3 or 4 or 5 points out there. Then I look to see what I need to know. Well, I'd like to know what it does between these two here, wouldn't I? So that would be at x equals 1. I'd like to know what it does over here. So that this is -2, so -3 or -4 for x. And maybe right here at x equals +1, right? So I'm going to try the x equals -1 first. See what that gives me. That's this yellow band here. If I put in -1 for x, y then is going to be -1 squared plus 2 times -1 minus 3. What is -1 squared? 1. What is 2 times -1? -2, then minus 3. 1 plus -2 is -1 minus 3 is -4. So when x is -1, y is -4. So that's right here. Let's try when x is -3. So it's -3 squared plus 2 times -3 minus 3. What is -3 squared? 9. 2 times -3? -6 and minus 3. 9 plus -6 is 3 minus 3 is 0. So when x is negative 3, y is 0. So over here, negative 3, 0 is right there. We're getting a picture of our graph already. I'd maybe put in 1 for x and see what that gives us. That would give us 0 if I did it. Eventually, we're going to get enough points that we can draw a curve through this and figure out it looks something like that. So the key there is what I did there is I picked points, picked numbers for x, I put them on there, plotted them, and then I looked to see where do I need to find points in between them. Where would I need points in the graph? And that's what I did here was I needed to figure out what happened between this point and this point. Well, what's between that? X equals negative 1 is what's between it. So that's why I used the x equals negative 1 to figure out what was going on there. I wanted to figure out what was going on in between this point here and this point here. That's in the x equals positive 1. So that's why I used x. I could have used x equals positive 1 there. I didn't do it. But. And the same thing, I wanted to know what happened on this side. So I had to know x something less than negative 2. So I used negative 3. So it's not an exact science as to what points you're going to use here, what numbers you're going to use for x. It's just a matter of putting some points out there and figuring, okay, I need to be comfortable knowing what this looks like, I need to find some points here. So that's x equals this value. Let's try it. So if we have something like this here, where we have an equation, and I actually gave you values for x to use here to see if you can graph them. These first two here are actually pretty simple. If x is negative 2, what's y have to be here? If the equation is y equals 3x minus 2. Yeah, 3 times negative 2 is negative 6 minus 2, negative 8. So we've got negative 2, negative 8. That's a point. X is negative 2, y is negative 8. If x is negative 1, you'd put negative 1 in there for x. 3 times negative 1, negative 3 minus 2, negative 5. So x is negative 1, y is negative 5. It's right there. If x is 0, you put 0 in for x. 3 times 0, 0 minus 2, negative 2. So 0, negative 2 is a point. Well, we're starting to suspect right now that this might be a line. If x is 1, what's 3 times 1? 3 minus 2, 1. So 1, 1 right there. And yes, this sure does look like it's going to be a line. And it is. Like that. The next one over here, same type of thing. Y equals 6 minus x. If x is negative 2, what is 6 minus a negative 2? Careful. 6 minus a negative 2 is 6 plus a positive 2, or 8. So you got negative 2, 8. If x is negative 1, what's 6 minus negative 1? 7. Negative 1, 7. If x is 0, what's 6 minus 0? 6. You've got 0, 6. If x is 1, what's 6 minus 1? 5. So you've got 1, 5 is right there. Any questions on how I'm plotting these points here? Okay. How about on where I'm getting these numbers in the table, the y numbers in the table? Any questions on that? Well, whatever number I have here, I'm putting it in here where the x is. So this is 6 minus x. So yeah, I'm just taking 6 minus whatever this number is I used for x. That formula tells me what I have to do with that number. Here it was 3x minus 2, so I'd do 3 times whatever number I chose, and then subtract 2. So here, if I'm going to use x equals 2, 2 goes in there for x. 6 minus 2 is 4. So it's 2 comma 4. So 2 4s right there. That one also makes a line. Well, I want you to try these two in your notes. See what you can do with them. I will warn you, neither one of these two forms a line. Just as a check, what'd you get for the y coordinate when x is negative 2 here? 1. So negative 2, 1 right there is a point that's on our graph. So if x was negative 1, what was y? Y was 0. So negative 1, 0 right there. If x was 0, what was y? 1. So 0, 1 is right there. Again, not a line. If x is 1, what's y? 4. 1, 4. Not enough to graph it quite yet. But if I knew what happened over here on this side, it might be. So this value here would be x equals what? Right there. That's x equals negative 3, right? So if I put x equals negative 3 in there, I end up getting 4. So it's right there. Now I can comfortably draw a curve through that. Something like that. That curve, by the way, occurs enough. It has a name. It's called a parabola. It usually occurs when you have x squared as the highest power or the degree of that expression. Did anybody get number 4 done? Okay. Okay, well, we'll put them on there. If you got x is negative 6, what's y? 0. So negative 6, 0 is right there. Negative 6 and 0. If x is negative 5, what's y? 1. So negative 5, 1 is right there. X is negative 2, what's y? 2. So negative 2, 2 is right there. If x is 3, what's y? 3. So 3, 3 is right there. We get a curve like that. Now, I'm going to point something out here. On all of these graphs here, 1 and 2, and on 3, what did I do at the both ends of the curve? Put arrows. Good. On number 4, what did I do? Yeah, I put an arrow on one end, but not the other. Can anybody think of why that would be? It has to start there. If x were negative 6, or sorry, negative 7, what would happen? Well, I put in negative 7 there. What's negative 7 plus 6? Negative 1. What's the square root of negative 1? Your calculator is going to tell you get lost, right? It's an error. We cannot take, with real math, we cannot take the square root of a negative number. So x can never be smaller than negative 6. So that has to stop there. It's something called an asymptote. And what it does is it limits, I don't know why that didn't come out, it limits where the graph can be put on our, it limits what points can be graphed is what it does. And for here, that asymptote does not allow us to go to the left of negative 6 because x cannot be smaller than negative 6. So then we got similar ones here. I'm just going to give you number 5 here. Y equals 3 plus 3x is going to look like this. It is a line. Number 6, Okay, apparently it didn't like my line. Number 6 is stay. Okay, we're going to try this one more time. Huh. Wow. All my other stuff is still there. Well, let's see if I put dots in it. See what it does. Let's just I'll switch it and we'll come back to it. And so they're getting really close to getting their new computer back in a box. Okay, well, that one stays. It stayed. Okay, so now I'm gonna start to talk and it'll disappear again. Someone's on our network somewhere got remote access to my computer. Just trying to piss me off right now. So anyway, this other one over here. No, it's one of the computer texting. Oh, let's see if I can get him to break his new computer. So this is y equals 2 to the power of x. If x is -2, if you put it in your calculator, 2 to the power of -2, it will give you an answer. It's 0.25. So -2, 0.25 is my point. Somewhere in there. Stay. 2 to the power of -1, if you punch it in, is going to be 0.5. So -1.5 is right there. What's 2 to the power of 0? What's anything to the power of 0? 1. Anything to the power of 0 is 1. 2 to the power of 1? 2. So we got 1, 2 there. 2 to the power of 2? 4. 2 to the power of 3? Would be 8. And we can keep going, but we know what this looks like right about now. Looks something like that. This again is an asymptote here on the x-axis, because that line will get closer and closer to the x-axis, but it'll never reach 0. I can have 2 to the power of -100, and it's always going to be slightly larger than 0. So that's an asymptote. The graph will get closer and closer to that line, but it cannot cross it. Cannot touch it or cross it. I'm going to have you guys try these two right now, 7 and 8. To see if you're heading in the right direction here for the number 7. If x is -2, what does y become? -9. -8 to the, or -2 to the third power is -8, -1 is -9. So it's actually slightly off the bottom of the graph here, right there. Is at that point. If x was -1, what did y become? -2. Okay. So -1, -2. How about a 0? -1. 0 to the third is 0, -1 is -1. If x is 1, 0. And if x is 2, 7. See, kind of a weird looking S-type curve like that. You guys need more time for number 8? Okay, I'll give you a couple more minutes. Okay, let's head you off here. So over here, if x is -8, what is 8 divided by -8? -1. So if x is -8, y is -1. That's a point right there. If x is -4, y is -2. So -4, -2. If x is 0, 8 divided by 0 is error. Your calculator says bad things. How about 4? 2. So that's right there. How about 8? 1. So that's right there. Well, that sure don't look like much. So let's pick some more points. Let's try -2. If x is -2, what's y? 8 divided by -2 is -4. So that's there. How about -1? If x is -1, what's y? -8. That's right there. I could try 1 and 2 is going to give me points like that as well. This is actually 2 separate curves. We have there and we have here. We once again have asymptotes. We have an asymptote here, and we have one here, there. X can never equal 0 because you can't divide by 0. Here, the way it's set up, the way that equation is, y will never equal 0 either. So there's an asymptote there. The graph will get closer and closer to both of them, but it'll never touch each and never cross each. I think you guys have had enough graphing with those for today. What would you do with something like this? How would you graph that? Well, if the equation is y equals 3, if x is -2, what's y? 3. If x is 0, what's y? 3. Okay, you get the picture. Y is 3 no matter what x is. Well, because x doesn't appear up here. So there's no place to put the x in. So y is 3, period. So any value I pick for x, y is going to be 3. So what that means is if x is -2, y is 3, x is 0, y is 3, x is +2, y is just plain 3. It is a flat line at y equals 3. The counterpart of that is what if I have x equals -2? Does it matter what y is? No, x equals -2 is right there, or there, or there, or down here. X equals -2 is a vertical line at -2. So pop quiz. What would the equation of that one be? X equals 7. Good. It goes at 7, so it's a vertical line. It's either x equals or y equals. Since it's vertical, it has to be x equals. So then this one would have to be y equals -3. Very good. There is a new quiz due tonight at midnight. Technically 11:59 p.m. Oh, not even 6. There's like 4 or 5 more quizzes to go. There's new homework due for Monday. And like I said, make sure you are looking back through comparing the grade book in my math lab to Blackboard, because if there's any assignments you've done late, there's a chance that I didn't catch it and I didn't get them transferred. So make sure that every grade that's in my math lab is in Blackboard. Okay, you guys have a great day, a great weekend, and I will see you all on Monday. I will be here for the next half hour or so if you want to stick around and work. We will be doing